morning, students. So it's being a first recorded video. I'm trying my level best to make you feel understanding the topic invertible functions. So the first question coming in our mind when we start with the invertible function is is every function possess its inverse or not? Of course, the answer is not. So how we can test whether the given function is invertible or not? So there are two testing methods we have in our syllabus. That is, first question was whether f inverse exists or not. So to find whether it is invertible or not, we are having two methods, as I told you. That the first method is whether the function is bijective or not. If it is bijective, then we can say the given function is invertible function. And other way to speak the same one by using the composition language. Composition of functions language. So already we have discussed so many questions based on this bijective, whether the function is 1 1 or onto. If the function is 1 1 or onto, we can say the function is bijective. If the function is bijective, its inverses exist. This we have studied in the topic functions. Now we also study the same one, whether the function inverse exists or not, or the function is invertible or not, by using the composition of functions. So here, to understand the same, first I will take the traditional method to find the invertible function or not by using bijective method. For that I am taking one question where we will find the existence of the inverse of the function, first with the bijective method, second is by using composition of function method. Okay, so let's take the question first. Now the question is the function which is defined from positive real numbers to 4 comma infinity. Positive real numbers to 4 comma infinity, where the function is defined as x square plus 4. So where here we wanted to know whether the given function possesses its inverse or not, right? So to find its inverse or whether it is a function is invertible or not, so first we'll find whether the given function is bijective or not. So we are using the bijective function method. So we can say first we will check whether f is 1 1 or not. For that we are using a regular method. We will suppose let f of x1 is equal to f of x2, right? So it means that according to the given function, it would be x1 square plus 4 equal to x2 square plus 4. So ultimately here you can say 4 get cancelled. 4 get cancelled. So you may simplify this expression, x1 square minus x2 square equal to 0. Here x1 plus x2, you can simplify like this by using an identity. So you can say here it implies that x1 plus x2 cannot be 0. Hence x1 is equal to x2 is only possible case left. The question arises, why the sum of these two numbers is not equal to 0? Reason, if you observe here, when we say f of x1 is equal to f of x2, what does it mean? x1 comma x2 belongs to domain. Domain, what is the domain of this function? This is positive real numbers. Hence, if x1 and x2 are belongs to positive real numbers, hence their sum never be equal to 0. So we are left with only one condition, that is x1 is equal to x2. So here we have satisfied the condition that if f of x1 is equal to f of x2, we have arrived the result with x1 is equal to x2. So it is sufficient to say the given function is 1, 1. So therefore, we have proven that f is 1, 1. Now, this is half portion done. Now, to say it is bijective, we need to prove it is onto also. So for that, I am taking now onto process on the second side. Right. So we are going to check whether the function is onto or not. For that, what is the process? Already we have studied this. First, we'll assume the given function equal to y. Let f of x is equal to y. So f of x is equal to y means the given function x square plus 4 equal to y. Hence, we'll solve for x. So x square equal to y minus 4. Then x is equal to plus minus under root of y minus 4. But I can ignore the negative sign because it is equal to x, and what is x? That is always belongs to the domain, and what the domain is given in a question? Positive real numbers. Hence x is also positive real number. It cannot be a negative number. Hence it is reduced to what? X is equal to under root of y minus 4. So this is what we arrived with x. And then we'll check whether the codomain of the function is equal to range of the function or not. So what is a codomain of the function? Codomain of the function is the interval between 4 to 8 including 4. So we'll check whether the range of this function is equal to codomain of this function or not, right? So if you see, if x is a positive real number, so ultimately under root y minus 4 is also a positive real number. Am I right? So hence, what do you say here? If x is belongs to positive real number, so it implies that under root y minus 4 is also must be greater than or equal to 0. Y is greater than or equal to 4, which implies that y belongs to 4 comma infinity, right? So तुम ऐसा बोल के करोगे ना, same here. So what we are discussing is, if here the x is belongs to the domain positive real numbers, so which is equal to under root y minus 4, it must to be greater than or equal to 0, which also implies y minus 4 is greater than or equal to 0, which implies y is greater than or equal to 4. So I can write that the y is belongs to 4 to infinity. So if you observe this statement, y, right, we got the range here. So we are simplifying this equation. Let us assume this as 1. If we simplify the equation for finding the possible values of y, means we are finding the range of the function. So if we observe the range of the function and the codomain of the function, both are same. Hence, we can say that given function is onto. So, for a given question, we are able to prove it is 1, 1 as well as it is onto. Hence, by the definition, you can say f is 1, 1 and onto, or in short, you can say the given function is bijective. If it is bijective, it means that the given function is said to be invertible function. So what do I mean by invertible function here? If the function is 1, 1 and onto, we can say it is bijective. If it is bijective, the function is said to be invertible. So every bijective function is invertible. It means whose inverse is possible. We can say here f inverse is exists, means we can find its inverse. So this is one of the testing process whether the function is invertible or not, just by proving the given function is bijective or not. So this is the one of the technique we have used in previous lectures also. So now we are going to understand the same by using the composition language. So before going to that, we can find the inverse just from the onto process. So what is the expression we got? X is equal to under root y minus 4. Here under root y minus 4 is called inverse of the given function. So I can write the inverse of the function from the onto process like this. See, just have a look. Therefore, I can write the f inverse function, f inverse y, we call it as f inverse y because we got the function in terms of y. So f inverse y written as y minus 4, and we know that what are the possible values of y, already we got it as, where y is belongs to 4 to infinity. So we got the inverse of the given function because it satisfied the condition that it is bijective. Hence its inverse as written as under root of y minus 4. If the function is x square plus 4, its inverse is under root of y minus 4, where y belongs to 4 to 8. Therefore, we can say f is a function. If f is a function defined from positive real numbers to 4 to infinity, it implies that f inverse is defined from 4 to infinity to positive real numbers. Because it is from x to y, then f inverse will be y to x. And what are the possible values of y? We got it as 4 to infinity only. This function is defined. Hence, f inverse is said to be 4 to infinity to r plus. So here we can also speak if f of x, the function is defined as x square plus 4, then its inverse, f inverse x, is also written as under root of x minus 4. So it doesn't matter whether you are expressing the inverse in terms of y or in terms of x, both are giving the same meaning. So if you are confused with the variables, keep it f inverse always in terms of y. So we can also speak f inverse y is equal to under root of y minus 4. So this is the actual concept to find whether the function is invertible or not. So I repeat in short, first to check whether the function is invertible or not, there are two different methods we have. The first method is bijective method. So first we'll take the function properly, we'll write its function from domain to codomain and the function. Apart from that, then we'll prove first the given function is 1, 1 and onto. Once you prove it is 1, 1 and onto, we'll declare it is bijective function. If it is bijective, means its inverse exists. Its inverse can be found from the method which we have already done for onto. That is, here you can get the inverse function in. Fine. So finally, again, I am just recapping the things in short. See, the first question is the given function was r plus 2 this positive real numbers to this interval, where we call it as domain of the function, which we call it as codomain of the function, and this is the function defines. Now we already proven that this is invertible. Hence we are able to write its inverse in terms of y. That is what? F inverse y is given as under root of y minus 4, where f inverse is a function defined from 4 to infinity to any positive real numbers. So if you observe the inverse function, 4 to infinity is domain of the inverse function, and r plus is codomain of the inverse function. So finally, if you observe if you relate the function and its inverse, one common thing you will find: the domain and codomain of the function get reversed. So what does it mean? If the function is defined from set x to y, if there exists inverse, then invertible function is always defined from y to x. So this is the function we called as what? Invertible function through bijective method. So in the next video, we'll continue the same topic by using the composition of the functions. So in a previous video, we have already discussed whether the function is invertible or not by using the bijective method. The same again we are going to test the given function is invertible or not by using the composition method. So first we'll try to understand how can we determine whether the function is invertible or not by using the composition method. For that we need to understand the definition, right? So if a function is defined from set x to set y, R domain to codomain, if there exists a unique function g, which is defined from y to x such that g circle f of x is equal to x and f circle g of y is equal to y. I repeat, we are going to test whether it is invertible function or not. So we are going to first understand the definition whether it is invertible or not. So if the given function is from x to y, if there exists a unique function g from y to x, then such that it satisfies both the condition. G circle f of x should give x and f circle g of y should give y. So first we'll define the function g, though it is not given in the question. From the given function f, first we'll define the function g from y to x, and then we'll go for these two tests ki gof and fok will give this x and y variable or not. Then only we can say the g function which is defined is called the inverse of the function. So we'll take the same question with the help of this with the help of this definition, we'll prove the function is invertible or not. So I am taking the same question here. The question was, previously we have discussed this question, again I am taking the same one. F is a function which is defined from positive real numbers to 4 to infinity, where the function was x square plus 4. So now again we are going to test whether it is invertible or not, but this time we are using the composition definition. So for that, first we'll define the function g. Without g we cannot do this operations. For that, what we'll do, first we'll let this function is equal to y, just we were doing it onto process. So first we'll let the given function f of x is equal to y. So ultimately x square plus 4 equal to y. Ultimately x square equal to y minus 4. Then x is equal to plus minus under root of y minus 4. And as we know that x is belongs to positive real numbers, we can ignore the negative sign. So x finally equal to under root of y minus 4. So the function which we got in terms of y is called g function or g of y function. So hence the g function g of y is taken as under root y minus 4, where the possible value of y should be 4 or greater than 4. Hence we are taking g is a function under root of y minus 4, where g of y function is defined from 4 to infinity to positive real numbers. So I repeat the same process. Here first we'll assume the given function f of x is equal to y. Hence we'll solve for x. Whatever the function you got in terms of y, we'll define it as g of y. So this is g of y function, or simply you can say g function, where g function is defined from 4 to infinity to r plus simply. Now we have to check whether this is the function g is the inverse of f or not. For that we'll take first gauge operation and then we'll take fog operation. Okay, so I am taking now the gauge operation first. Right. So gauge of x. First I am taking now now gauge of x, right? So first we'll solve for it. It means that g of f of x. So what does it mean, g of, what is f of x given in a question? This is x square plus 4. So we'll write x square plus 4 in place of that. And what is g of x function? We got it as g of y is this. So we are going to substitute this value in this function, which will ultimately give under root of x square plus 4. So here plus 4 and minus 4 get cancelled and we are left with under root of x square, which can be written as plus r minus x, but we can ignore minus x. Already I have told you that we are dealing with only positive real numbers. Hence we got the result as x. When you operate g circle f, gauge of x is equal to x. So we have satisfied the first condition. And what we go for now? The second operation, that is fog of y should be equal to y. So I am taking now second condition, fog of y. What does it mean? F of g of y. What does it mean? F of, what is g of y? Already we got it as under root of y minus 4. So we are solving further. F of under root of y minus 4 means in place of x we are going to substitute under root y minus 4. So it will give y minus 4 the whole square plus 4. So hence here square and root get cancelled. So y minus 4 plus 4 is left. Minus 4 plus 4 get cancelled. We are left with y. So if you observe, the gauge operation will give x and fog operation will gives y. It means that g is a function which is defined satisfying both the condition. Hence g function is called inverse of the given function. Hence we can say that if the function f of x is x square plus 4, which implies that its inverse, f inverse, also known as what? G function, which is equal to under root of y minus 4. Already we have seen that this function inverse was under root of y minus 4. We also got the same conclusion with the help of composition language. So here there are two different techniques to prove the given function is invertible or to determine the given function is invertible or not. The first one was bijective method, second one is composition method. So for that we need to understand the definition. If f is a function defined from x to y, if there exists a unique function g y to x such that gof of x must be x and fog operation must give the variable y. If it is so, then we can say the g function is inverse of f. So first, from the given function, we'll define g function simply by taking the operation like let f of x is equal to y and solve for x. Whatever the function you will get in terms of y, that will consider as a function g. Once you define the function g from the given function f, then we'll go for gof of x and then fog of y. So gof of x is x, fog of y is y. Hence the defined function g is called the inverse of the function f. Hence the inverse of the function is under root of y minus 4. We can write if the function f of x is x square plus 4, then its inverse is written as g of y is under root of y minus 4. So this is the conclusion we got from the two processes. So finally I will write one common statement which can be applicable in both the methods. See, right. So if a function which is defined from x to y, then there exists a unique inverse, right? That is f inverse, which is defined from y to x. Fine. So if this is a function, so in this function, if it is a domain and it is co-domain of the function, inverse में आप observe कर सकते हैं, this y become the x become the y, means co-domain become the domain and the domain become the co-domain. You may also relate that here. See, domain and domain and codomain and codomain. So you can simply observe the beauty of this function is if the function possesses its inverse, it always defined in this way. So if the function is defined from x to y, its inverse is defined always from y to x. It's just a mirror reflection of each other. Hence, domain of the function is always equal to codomain of the inverse function. Our codomain of the function is always equal to inverse of the domain of the function. Instead of codomain, we usually use the language range, because in function language, codomain is basically equal to range. So we can say the function is defined from domain to range, then its inverse is defined from range to domain. You may also say, sorry, it is domain and it is range. So simply here the domain of the function is becomes range of its inverse, vice versa, and range of the function is defined as domain of its inverse. So this is a beautiful learning outcome of the invertible function through different methods. Now we'll take one more question where we'll find the inverse of the function with the help of composition function. Yes. Students, already we have discussed lot many things under the invertible function topic. With the topic with the help of the second question where the function is defined like every real numbers except minus 4 by 5, two real numbers. It is domain and it is code of the function, also defined as range of the function. And we know why it is eliminated, because the function is defined, a rational function, like where denominator cannot be 0, it means x cannot be minus 4 by 3. Hence, the domain of this function is here r minus every real numbers except minus 4 by 5, and the range of the function is every real numbers. So this is a function given. Now what we are going to check, whether this inverse of the function is exist or not. So for that we'll take the composition of functions methodology. For what that speaks, first we'll define a function g of y, and then we'll go for the test gof and fog. So to define g function, we'll start with like this. Let the f of x is equal to y. So what is the f of x function given? 4x plus 3 by 3x plus 4 equal to y, and then we'll solve for x. How can we solve for x? By doing simple cross multiplication method. So it would be 3xy plus 4y, and then group the x terms one side and other terms the left hand side. It would be 4y minus 3. You can take x as a common factor. 4 minus 3y is left. Then it would be 4y minus 3. Hence x is equal to 4y minus 3 by 4 minus 3y. So this is what we got the function x in terms of y, which will define that this is the g of y function. We are assuming this is g of y function. Right. So finally we got the g of y function, which is defined as 4y minus 3 upon 3 minus 4y, where y cannot be what? Sorry, y means 3 minus 4y cannot be equal to 0. It means that y cannot be equal to 3 upon 4. So first we'll define the function g by taking f of x is equal to y. We'll solve for x in terms of y. So we call it as g of y function. Once we got the g of y function, then we'll go for the test by using fog and gof language. So what is the first test we are going to take as gof? G circle f of x must be equal to x. So to test this, first we'll take the gof. G of f of x, left hand side. And what is f of x we have? F of x as c. This is. So hence we are substituting this value 4x plus 3 upon 3x plus 4. Now we'll solve further. And what is g of y function we have? This is. So in place of y, we are going to substitute this value. It means 4 times of 4x plus 3 by 3x plus 4 minus 3 upon 3 minus 4 times of 4x plus 3 by 3x plus 4. So once you solve by taking LCM and grouping and by cancelling, you will definitely get x. You will definitely get x. I am leaving this simplification part for you. So here we are able to prove g circle f of x is equal to x. Similarly, if you are able to prove fog of the function, f of g of y is equal to y or not. This is the second test. For that again we are taking f of g of y, left hand side portion. Then we'll substitute g of y value. What is g of y we have? Here, this is g of y. So 4y minus 3 by 3 minus 4y. Now we'll substitute this value in the f of x function, where we can write 4 times of 4y minus 3 by 3 minus 4y plus 3 upon 3 times of 4y minus 3 upon 3 minus 4y plus 4. So once you simplify this by taking LCM and all, you will definitely get y. So here we are able to prove that G circle f of x is equal to x, f circle g of y is equal to y. Hence, g of y function which is defined in the process is called the inverse of this function f of x. So this is the concept to find whether the given function possesses a inverse or not. So finally we can write the statement as say inverse of the function. So here the inverse of the function is simply g of y, which we are already defined in the process. So therefore f inverse x, inverse of the function, is nothing but simply the g of y function which we have defined. Hence we can write it as 4y minus 3 upon 3 minus 4y. Otherwise, you may also write the inverse of the function in terms of x. So f inverse x can also written as 4x minus 3 by 3 minus 4x. Right? So simply here the method, I think we have understood the invertible function concept through two different questions. We have verified that there are two possible ways to find the invertible function. One is the bijective method. By proving the given function is 1, 1 and on 2, that is bijective. Once it is bijective, we can declare it as invertible function. Hence, we can simply write its inverse from the onto process. Second way is by defining, that is what composition language, by defining the g of y function from the given function f of x, and then we'll perform two operations. One is g circle f of x is equal to x, and the second one is f circle g of y is equal to y. So once we able to prove these two statements are true, then the defined function g of y is called the inverse of this function. Hence, inverse of the function is nothing but g of y function, that is this, also written as f inverse x is equal to 4x minus 3 by 3 minus 4x. So this is all about the invertible function. We'll take one more question to finish this topic, and apart from that question, then we'll discuss three more important properties in the next video. So keep on watching. Okay, fine. So we'll end this topic by taking this final question here. So just read the question carefully. What is there? If the function f from real numbers to real numbers is defined as x plus 3 by 3, and another function g, again real numbers to real numbers, is defined as 2x minus 3. So there are two functions defined, f of x and g of x separately, and then we have to find. There are three subparts of this question. First we'll find fog, we'll find gov, and in third part we'll check whether inverse of the given function f is g or not. So for that, first we'll finish the fog and gov, first part and second part, in usual manner. So what is the first part we need to complete? That is, first we'll go to find fog. How to find the fog? It means that we can write the fog as fog of x, because whatever the values we are taking from the domain of this function only, and domain is what? Real number, means that x may be any real number. So here it can also written as f of g of x. So hence f of, what is g of x function given as? 2x minus 3. We are writing that. And then what is the function given as? F of x is given as x plus 3 by 3. So hence in place of x, what we have? 2x minus 3, we are substituting that. So 2x minus 3 plus 3 by 3. Hence by cancelling this, you will get 2x upon 3. So if you observe the fog value or fog of x, if circle g of x is 2x upon 3, and the second portion is golf. So for golf also we can take, we'll start with operation by taking the variable x, which is always, the variable which we are taking is always belongs to its domain. And what is the function? F is from R to R. So whatever the x we are taking here, we assume that is x belongs to real numbers. So here we'll take it as g of f of x. Hence what is f of x? We have x plus 3 by 3. And what is g of x? We have 2x minus 3. We are substituting this value in the g function. So 2 into x plus 3 upon 3 minus 3. So hence, when you substitute this, simplify this further, you will get 2x plus 6 minus 9 upon 3. You will get 2x plus 3 upon 3. So this is the fog function value, and this is golf function value. If you observe, fog and golf will not give the value of x. Means when you substitute the function any x in the g of function, you should get y. If you substitute y, you should get x. But in the given two functions, fog will not give y and golf will not give x. Hence we can say here, by the definition, fog of x is not equal to x, and even golf of x is also not equal to x. So therefore g cannot be what? The inverse of the function. So our purpose is solved. Therefore inverse of f cannot be g because it not satisfying the given conditions. You can see here. So therefore third part is automatically solved. What is the third part they are asking? Is f inverse is g? Is function g will be the inverse of f? No. Reason is very clear. From first and second part you can simply say that they are not satisfied by the definition of the fog and golf. So it is sufficient to speak the whether the function is invertible or not. If the invertible or not, then we'll find the inverse by using the composition language. But in this question, what the difference is, we are not defining any g of y function. Already the function g of x is defined. Hence, just we are checking whether the g of x's function is inverse of f or not. For that, first we'll take fog and then golf, and then we'll conclude like this. Hence, the given function g is not at all the inverse of the function. Fine. So this is all about the invertible function. So I hope you have understood the topic very clearly. If it is not, so no need to take tension. We will be in touch through online classes. I'll intimate you through WhatsApp at what time we can be in a meet where you can discuss directly with me the doubts regarding this topic, right? So thank you all of you, and take care yourself.